Good day, everyone. So now we are tasked to investigate a VLAN implementation using these three switches and 9 PC. So this topic includes two objectives, which are to observe broadcast traffic in a VLAN implementation and to observe broadcast traffic without VLANs. So, as its background, we will be observing how broadcast traffic is forwarded by the switches when VLANs are configured and when VLANs are not configured. So, let's start. So, at this juncture, we are going to proceed to the second part of this investigation of a VLAN implementation, which is to observe broadcast traffic without VLANs. So, for the first step, clear the configurations on all three switches and delete the VLAN database. So, first return to the real-time mode here and delete the startup configuration on all three switches. So what command is used to delete the startup configuration on the switches? So first is to click the switch. The command to be used is the erase startup config. Yes, confirm. And then delete VLAN dot dat. After that, yes, confirm. And after that process, we need to reload the switches. So use the reload command in privileged exec mode to reset all the switches. So wait for the entire link to turn green. And to accelerate this process, click fast forward time located in the bottom yellow toolbar. So we need to reload. You need to use the reload command there. Confirm. As you can see, it's reloading. And yes, what I did in the switch tree was also the thing I did in the two other switches. So you just need to follow these commands. Click this fast forward button there. So we need to proceed to the step three of the second part objective, which is to click the capture forward to send ARP requests and pings. So after the switches reload and the link lights return to green, now the network is ready to forward your ARP and ping traffic. Select the scenario 0 from drop down tab to return to scenario 0. Okay. So from the simulation mode, click the capture forward button to step through the process. Notice that the switches now forward the ARP request at all ports except the port on which the ARP request was received. There. So this default action of switches is why VLANs can improve network performance. Broadcast traffic is contained within each VLAN. So when the buffer full window appears, click the previous events button. There, as you can see, I think it has reached the buffer full, and this window will appear just a few seconds. There, just click the view previous events. So that's how we investigate the VLAN implementation. So these reflection questions were just part of the summary of how we have learned so far in this topic. So first, if a PC in VLAN 10 sends a broadcast message, which devices receive it. So all the devices that will receive are on the VLAN 10, just like PC1, PC4, and PC7. So same goes with second question and the third question. So for the fourth question, what happens to a frame sent from a PC in VLAN 10 to a PC in VLAN 30? So it will be dropped there. So for in terms of the ports, what are the collision domains on the switch? So each port is a separate collision domain. And the last one, in terms of ports, what are the broadcast domains on the switch? So they are divided by the number of VLANs in the switch. So that's all for the topic, investigate a VLAN implementation. So there, bye, thank you. So first, let's move to the part one of this VLAN implementation, which is to observe broadcast traffic in a VLAN implementation. So the first step we're going to do is to ping from PC1 to PC6. So we are going to wait for all the linked lights to turn to green. So to accelerate this process, we need to click the fast forward time located at the bottom toolbar, this one. Since it has all turned into a green light, so we can proceed to the next step. Click the simulation tab and use the add simple PDU tool. We need to click PC1 and then click PC6. So here, simulation tab, we're going to add simple PDU from PC1 and then next to PC6. There. So click the capture for forward button to step through the process. Observe the ARP requests as they traverse the network. When a buffer full window appears, click the View Previous Events button. So there you can observe the flow of the message from PC1 into the switch 2, and then so were the pings successful? Explain. Of course, no, as you can see. The pings were not successful because PC1 is on a different VLAN than PC6, which won't allow these devices to communicate with each other because they are separated logically. Because of the VLAN differences, it won't allow devices to communicate with each other as they are logically separated. As you can see, PC1 is on the VLAN 10 compared to PC6, which is on the VLAN 30. Its VLAN differences has not allowed them to communicate as they are logically separated. So proceeding into the next step of the part 1, we are tasked to ping from PC1 to PC4. So click the new button under the Scenario 0 drop-down tab. Now click on the Add Simple PDU icon on the right side of Packet Tracer and ping from PC1 to PC4. Same process, but on a new button, we're going to uh, see how this scenario works. So there, we need to click this new button, and then we're going to add a simple PDU icon on the right side of the packet tracer and ping from PC1 into the PC4. There, PC. and then clicking the capture forward button to step through the process and observe how the ARP requests traverse the network. So were the pings successful? Yes, because PC1 and PC4 both belong to VLAN 10. So the path of the ARP request is the same as before. Because PC4 is the destination, it replies to the ARP request. PC1 is then able to send the ping with the destination MAC address for PC4. The communication of the ARP requests were successful since they belong to the same VLAN, which is on the VLAN 10. So you need to click this switch, proceed to the CLI, and type this command, enable, and then show VLAN brief. After that, it will present you the following: the VLAN, the name, the status, and the ports. It will the PDU will go to these ports. So what I have done in this switch were also the code or the command I did on the switch 1 and the switch 2. So another question was, when the packet reach switch 1, why does it also forward the packet to PC7? Because PC7 also belonged to VLAN 10 and the ARP request was for VLAN 10. Switches will forward to any devices that are connected to VLAN 10 in their port. So if PC1 has sent a message to the PC7, it will also send the ARP request to the PC which has the same VLAN as the PC1 and PC7 which is PC4. So the same goes to PC2 and to the other PC which has the same VLAN which is 20 and so on and so forth.